I've been running a bunch of security workshops lately where I spend a couple of days with software developers going through all these different common web risks. And one of the risks that we always seem to spend a bit of time on is cross-site request forgery, or CSRF. And recently I had a few people asking me about some fairly fundamental mechanics of how this works. So I thought what I'll do is I'll just do a video, right? And I'll just do the whole thing end to end, uncut and unedited, and none of the normal sort of nice Pluralsight-ish polish that normally goes onto it. But you'll get to see a heap of stuff, and hopefully that will help answer the questions that are coming up. So here's what I'm going to do. I'm on this website of mine, hackyourselffirst.troyhunt.com. It's a deliberately vulnerable website, got holes all through it. But it's a great website for doing demos about security risks. And I'm presently logged in. You can see it says Hello Troy up there to the top right, near the search box. And as I'm logged in, I can go and look at things like change password. And when I go to the change password page, because this website does so many screwy things, it's already got my password in here. So I can go down, inspect this, we'll zoom in on that guy a little bit, and we can see my password there is password with a 0 instead of an O so that the hackers don't know what it is. Don't do that, they've worked that out. Regardless, the point is that it shows me my password here. And we're going to come back and have a look at this little feature to see how my password is later changed by a CSRF attack. Here's the important thing though. Let's pump those dev tools back up again. I'm going to go to the network tab, and then I'm going to go down and change this password. Now let's have a look at the HTTP request that happens when we do that. And in particular, I want to point out 3 parts of this request that are key to the premise of a CSRF request. So the first part is the request URL. So have a look at this. This is our entire URL. All right, just goes to /account/password. The next part is the method. It's a post. So the HTTP verb being used is a post. We're going to be sending data to the server. And then down the bottom, we have our form data. All right, so here is 2 fields, new password and confirm password. They're both obviously the same value because that's how password change form works. So here's the important thing. There are 3 different things here we need to remember. Where we're sending the request to, so that's the account change password page, how we're sending it, so it's a post, and what we're sending, the form data, where, how, and what. If I, as a malicious hacker, can replicate that request and trick someone else's browser into issuing it to the server while they are logged in, I will be able to change their password. Now this is important too, right? I am logged in, and the reason I'm logged in is because I have this. I have an auth cookie. And the auth cookie is the little piece of data that's sent on each request after you've logged in, which lets the server know who you are. And I often ask people, I say, how do you send a cookie to a website with a request? And they go, well, like we don't really think about it. And that's kind of the point, right? You don't think about how to instruct the browser to send a cookie because it just does it automagically. Well, kind of automagically. If you've got a cookie that's valid for the domain and for the path and it hasn't expired, it gets sent automatically. Now in our CSRF attack, we're going to take advantage of the fact that that cookie gets sent automatically and becomes an authenticated request. So here's what we'll do. Let's go over to this page here. So this is just a page on my local machine. Typically, you would have this being some form of a malicious page on some other website somewhere. Could even be distributed by an ad network, a compromised ad network. That happens all the time. Now here's what's going to happen. I'm just going to reload this page. And what we'll do is that now it's finished loading, we'll go back over to here. I'm going to go and just click that link to my change password page again. And we're going to have a look at what my password is now. Let's see what we've got in here. All right, here we go. New password is called hack pword. So my password has been changed, and it was changed by this tab over here. Let's view source and have a look at how it's done this. So this is a really, really basic page. And here's all that happens. On load, we submit a form called CSRF form. That's this guy down here. Now the action is the path to change passwords. So that was the first piece of those 3 pieces of data I talked about before. The method is post. That's the second piece of data. The third thing is these 2 values here. We have a new password and a confirm password. So that was the third thing that I spoke about. So what happens here is that this request is a perfect representation of this request over here. It's exactly the same structure. Goes to the same place, same method, same structure of the request body. Now, because we're using cookies for authentication, which is fine, cookies are probably the best way we have of doing it at the moment. Because it's using cookies, if we open up our DevTools here, we go to our Network tab, reload this page, have a look at what happens when the request goes. So first request here, this actually loaded the HTML page. We can see just a little bit further up. It then automatically submitted the form. Okay, so that's this request here. And now this request looks pretty much identical to the request we just saw before on the legitimate site. There's the URL, there's the post. Down here, our auth cookie is there. I didn't have to do anything to send the auth cookie in here. I don't have to know anything about the auth cookie because it gets sent automatically. So the auth cookie is there. And then of course we've got the same form data in the body. So all this page has done is replicated the original request. And it's just simply tricked the browser into doing it. Now, normally when this sort of request happens, there is not a heading which says CSRF demo. It is obfuscated away somewhere. It might be in a hidden iframe. In fact, that's one of the tricks I used here. When we do submit that form, it targets hidden frame, which is down here, which has display set to none. So what's actually happened here, when this page loaded, you can't see it, but it's loaded the entire change password page. And in fact, what you can see is you can see each of those assets in the change password page loaded. They're just all loaded up into a hidden iframe. So that's how the CSRF attack works. And the significant thing here about that attack is that the request is predictable. So what I mean by that is we just needed those 3 pieces of data: where we're posting it to, how we're posting it, and what we're posting. If we have all of that information, then we can mount the attack. So we need to add in some unpredictability. Now I'm going to go and open up Visual Studio. And the reason why I'm going to do this is because I want to show you how ASP.NET MVC implements anti-CSRF tokens. And tokens are our defense here. So here's what we're going to do. Let's take a new project. We will take that in the temp directory, which is fine, MVC. Right, make project. Now, it doesn't matter too much what your chosen framework is, whether it's ASP.NET or something else. This implementation of using anti-forgery tokens is pretty much the same in any platform that is implementing this form of defense today. But the reason I'm picking this one is that it's easy for me to stand up a project and it's got CSRF defenses built in by default. So I want to show you how they're built into the project, and then we'll actually run the project and we'll see how they work when someone tries to trick the browser into making a request. So let's have a look at a couple of things. I want to look at my views, and I want to look at account, and I want to look at let's go down to the register view just here. Now the view effectively has all the markup for the page, and it's got all of these HTML helpers here which execute server-side and do things like render controls. Now here's what's important. This guy just here, HTML.antiforgery token. So this is an HTML helper that creates an anti-forgery token. And I'm going to show you what the token looks like in just a moment. The thing I want to show you first though is what happens when we submit this form. If we go to our controllers, we go to our account controller, expand that guy down to the register action that takes the view model, we've got this, validate anti-forgery token. Now I'm showing you this, and again, it doesn't really matter whether it's MVC or something else, but I'm showing you this to explain that there are really 2 parts to this. So one is creating the token and setting it. The other is actually validating that the token is correct. Let me run this project now, and I'm going to show you what it looks like in the browser, because we're going to see something in our HTML and we're going to see a new cookie as well. So I'm just letting that guy run up. It's decided that it needs a new browser for some reason, so I'll drag that guy over here. And we're going to see two things here. So let's jump over to register. Here's a very generic looking registration form. Let's go into our document inspector just here, which is down there. And here are the things. So this one just here, this is our request verification token field in there with a whole bunch of other stuff. Let's try and make that a little bit smaller. All right, so we've got a request verification token, which is a hidden field. So nothing is rendered into the actual viewport of the browser. And we've got this great big cryptographically strong value in the source. Now that's part of it. Let's now go over to resources, cookies, localhost, and we have another token here. And what this is it's a paired token. It's not the same. This one starts with WS67. If we go back to our elements here, this one starts with KG underscore. So they're not the same, but they belong together. They're like mates, but they're cryptographic mates. You can't actually see what's inside them, but they do belong together. And I'm going to show you how that works in a moment. Now here's the thing. If we didn't have this input field, things are going to break. I'll show you. We'll just delete that. It's just deleting it out of the DOM, but that's all we need. Let's create this one. We'll create a password. And now we get an exception. We didn't have the request verification token field. Now this is important because if you're an attacker trying to trick the browser into making this request, you wouldn't have a request verification token field. You wouldn't know what to send them because this is random. Remember we saw that cryptographically strong token. We'll go back and reload the page so we get another one and look at it again. Into there, this one just here. So as an attacker, you can't just simply guess what this is. You can try, but I'll show you what happens. We'll do this. I'll grab that URL. I'll go and grab Firefox. We'll jump into another browser. So we're going to imagine this is our attacker now. And the attacker is going to go in here. They're going to inspect the element. They're going to find the token just there. We're going to take that token value. And we're just going to make sure we get the whole thing, which goes to there. And now let's drop that into Chrome. So let's imagine we're an attacker, and what we've decided to do is let's try and replicate the entire thing again. Let's try and replicate the attack. And we're going to drop this value in. So this is preset by the attacker. Let's have a look at what happens if we register now. Try a good old foo@bar.com. And password 1 there. These do have to match as well. Let's try that again. All right, so here is our problem. Anti-forgery cookie token and form field token do not match. Now this is why we have both a form field and a cookie. And this is one of the questions that people often ask. They say, well, why do you need both of these things? If you just had a cookie, then you'd have the same problem as before. The cookie would get sent automatically along with the auth cookie. You've got to have something else, which is the form field. Now, when you have the form field, the attacker cannot get that from you. They can create their own, which is what we just did, but it won't match the cookie. So now the only way the attacker can get around this is the attacker has to be able to set both the form field and the cookie. And the only way they're going to do that is if they can find a risk such as a cross-site scripting risk, where they can execute script in the client and do things like set their own arbitrary cookie. So you have to have a separate risk for that. But then even that won't work in many circumstances. And the reason why is because once you are authenticated, the cookie gets keyed to you. It is a cookie that belongs just to your username, not to anybody else. So what we're actually looking at here, on this registration page, we're not authenticated. And arguably, there's not a huge amount of benefit to having a CSRF defense here, other than the fact that it would stop you doing something like saying, let's go and create another form like the one that we did just over here, and now let's go and put this in a hidden iframe somewhere, and everyone who visits the page will automatically register on the target site, or automatically try and change a password on the target site. So it just sort of tries to avoid this mass ability to get people to make unintentional requests to a target. But it's more important when you're actually logged on, because when you're logged on, that's when an attacker wants to do something malicious under your identity. They want to change your password. They want to transfer money on your behalf, something like that. Now, taking this example back here again, if the cookie and the form field are both keyed to your username and your identity comes from the auth cookie, well, then the attacker's out of luck. They can't generate the right form field and the right cookie for your username. If they could, they'd just hijack your session and you'd have a different problem. So that's that. Now, there is another interesting thing here as well, which is people often say, well, should you only be able to use that token once? So should we regenerate the tokens in the cookie and the form each time? There are a couple of things with this. Here's one. What if we did this? If we actually had two tabs open at the same time and we're expiring the token on each one. So let's imagine maybe they're not both on the register page, but one's on login and one's on register. Now, if we opened the register page and we got a cookie and then we got a form field which was paired to it, and then we opened the login page and it set a new cookie and invalidated the old one, if we went back here and tried to click the register button, we'd have a problem because now the cookie would no longer be valid for this form. So that's part of the problem, and that's one question that comes up. The other question that comes up a bit is this meant to stop you from being able to submit the form twice? Well, let's have a look. We'll reload this to make sure I've got a nice clean cookie. Let's try our good old foo@bar.com. We might actually make that foo, because I've got to get it right again on the next one. Password 1. And now let's register. Now this is actually registering an account. You can see up the top right it says hello foo@bar.com. Now I'm going to log off. I'm going to show you why I've done this. I'm going to go back to register. I'm going to try and register again with the same account and the same password. And now let's try and register. Okay, and we get this exception, which is fine. But what I want to do is I want to reload this page and show you what happens. I get this normal prompt. Are you sure you want to submit the same form again? You say yes, continue. And I get exactly the same answer. Now let me show you what's actually happening with our tokens in here. If we go down into our requests, where are our requests gone? Network, there they are. We reload. Doesn't matter how many times you look at this. We have a look at the request. We go down to the bottom. We can see that we've got a request verification token which is being sent, and it starts with 1ZM-. Reload the page again. Let's look at the next request. Same token. So the same token's being used over and over and over and over again. We're not getting any exceptions here. The website's quite happy for us to submit the token over and over again. It hasn't expired it. And this is the point I want to make. So this implementation is not meant to be a double submit implementation. So it's not meant to stop you from submitting the same form twice, because as soon as you start doing that, you have all sorts of different problems. For example, things like the back button don't tend to work very well. You submit the form, click back, try and submit again, and the website says, no, not going to let you in. This is not designed to do that. And in fact, if we go and have a look at some of the OWASP references, so OWASP has got a lot of great cheat sheets for all this sort of stuff. They're pretty explicit, and they say, where did that go? In general, developers need only generate this token once for the current session. Now, what you'll see with ASP.NET in their MVC implementation is you will get a different token in the form field each time you reload the page, but it will always be the same cookie. So what it means is that you can have multiple tabs open at once, and they all share the same cookie. So your form field is per tab, or per DOM if you like, per rendered DOM, but your cookie is going to persist across all of those tabs in the one browser session. So that's how that one works. You can have multiple tabs open. You can do double submits. It's not meant to be an anti-double submit implementation. So hopefully that answers that bit. Now I'm going to show you one other thing which kind of seems like it's going to be a little bit legacy, but there is reason for this. Let's go and create a new project in here, and we're going to go and create a good old web forms application. Now, web forms is that thing we had before we had MVC, or at least that's the way most of us think about it. There is a lot of discussion about the fact these two can cohabit, and you will just use the best of each world, but people have tended to sort of move on. Regardless, the point is, I'm showing you this because web forms has no native controls for anti-forgery tokens. And indeed, when I think back, certainly to when I started doing web forms many years ago, it's something I probably never really even thought of. But it is a problem in web forms. And the reason I'm opening it up here is because the way they have addressed this in more recent versions is via a Visual Studio template. So if we go into our master page here, so this is the page which every other page in the site tends to adhere to, or rather inherit from, we'll see there's a whole bunch of CSRF stuff in here. And the reason I want to open it up is to walk through how it actually happens, because this sort of explains the mechanics of how an anti-forgery token is implemented. So I'm going to walk you through it, and we're going to go through it kind of quickly, and then that'll be the end of it. So this is the master page. So every single page on the site that inherits from this site master page is going to implement this model. And in fact, it's going to implement it automatically. So long as you're using the master page, you get all of this for free. I'll show you why. So we start off with an anti-CSRF token. And I didn't say it earlier, but CSRF and CSRF are exactly the same thing. So we declare what is going to be the name of our token key. And we also have a username key. Now you're going to see username used several times here, because as I said earlier, what we really want to do is key the anti-forgery token to the user. So we declare those two names. Now here's what happens on page init. So when this page is first firing up, it goes and gets a cookie, which is the anti-CSRF token key. There's this guy up here. Now what it's then going to do is look to see if that cookie exists. So does it exist already? Was it already submitted to the page? Or was it already submitted to the browser at some point and then sent back with this request? It's then going to try and see if it is a GUID. And the way Web Forms is doing it in this template is it's using a GUID for the anti-CSRF token. So it's going to try and see if it's a GUID, and if it is not null and it is a GUID, well then we can go down here, and what we can do is we can say, well look, let's get the value out of that cookie and we'll set it into this value just here. And then what we're going to do is we're going to set that in our view state user key. So there's going to be the view state that is specific to this user. Now, if the cookie wasn't not null, or wasn't a GUID, so in other words, if we did not have the cookie, then we're going to create a new one. And it is just a GUID. So we get a new GUID. So this, for example, this little else condition here, this might be the first time that you go to a form that's implementing this. The first time you come to the site, for example. So what it does is it generates it. It also sets the view state user key, which is exactly what we did up here. It then creates a new HTTP cookie, and it's using that anti-CSRF token key as the name of the cookie. So that was this guy up here. Now, what we're going to do is we're going to make it HTTP only, which is important because once the cookie is HTTP only, then it can't be read via client script. So if an attacker gets XSS on the page, it won't be able to access this. It then sets the value of that cookie to the new GUID that we just generated up here. Now that's fine, so that's our HTTP only attribute. It then looks to see if we're using forms authentication that requires SSL. Because if we do require SSL, and this request is made over a secure connection, then we want to set the secure attribute of the cookie to true. And if we do this, it means that the cookie will never be sent over an insecure connection. So if your browser makes an HTTP request for a domain that the cookie is valid for, then the cookie won't be sent. So now you can't have a man in the middle intercepting that value. And eventually the cookie is added to the response and it's set in the browser. We then register this event for page preload, which takes us down to here. And it says, okay, so this request has come in. If the request is not a postback, okay, so this would be in a case where we are making a GET request to load the page. So in that GET request, we're going to set the value of the view state anti-XSRF token key to the one that was just passed from the page's view state user key. The next line is the important one, anti-XSRF username key. And this is where we're going to key the token to this user. Because what we're going to do here is that if we have a value for the current identity, so if you're logged in and it knows who you are, then your anti-XSRF username key is going to be your username. If that's null, so you're not logged in, it's just going to be an empty string. It's going to be nothing. So this line is really important because what it's doing is it's saying if we know who you are, then your XSRF token is not going to be valid for anybody else, only you. So that is if it is not a postback. If it is a postback, this is where the validation happens. So this is really the crux of the implementation, which says, let us now make sure that the request isn't forged. And what it's doing here is it's going to check for that anti-XSRF token key, and if it is not equal to the one that we set earlier on up here, so this was when we first generated the token or when we loaded the page and we took one that was already in the cookie. So if they're not equal, in which case it could be a fraudulent request, the attacker hasn't sent the right token with the request, or if the view state anti-XSRF username key is not equal to the identity of the current user, or if that is null to an empty string, then we're going to throw this invalid operation exception. And that's all that happens. Now here's the important thing with this. All of this happens automatically using view state. It's really the same implementation as MVC with respect to the fact that there is data that is passed in a hidden field and there is data that is passed in the cookie. And when a form is submitted, they get compared. And the data is obviously also keyed to the current identity. So when you read through this, it kind of does your head in a little bit because there's a lot of token name keys here in anti-XSRFs and so on. And of course, there's the whole view state thing, which, love it or hate it, is there. But this is neat because it just works automatically on every page where you implement this particular master page. So that's pretty much all I wanted to cover. I know I've gone on for almost sort of half an hour here, and hopefully it's shown you, first of all, why we need to worry about XSRF to begin with, because we can forge a request and get someone's browser to issue it without them knowing, simply because their authenticated state gets sent automatically and they make it as a logged in request. It's also shown you how the implementation works within the likes of something like MVC. So how do we actually drop in that little HTML helper to generate the hidden form field? And then also how do we actually validate the fact that the token was correct? And of course that HTML helper in the case of MVC also sets the cookie. And then we're going to have a look at the implementation within web forms. And of course, when we did MVC, we had a look at what happens when you don't send the token in the form field, or what happens if you try and create it using someone else's token. So hopefully that gives you a really good idea of just how XSRF actually works and why, regardless of which framework you decide to use on the web, you do need to have defenses for it. I hope this has been a useful little demo.